Hello there. I hope all are having a good day out there. So today's lecture is going to be about gear trains, which is a part of kinematics of machinery, a very important topic. And I'm Amos Gamaliel David, Assistant Professor, Department of Mechanical Engineering, Panimal Institute of Technology. So let's move on to the first slide. Now, what is a gear train? When two or more gears are made to mesh with each other to transmit power from one shaft to another, such a combination is called a gear train. When there are just two or more, it's called as a gear train. Gear train is also called as toothed wheels because it's a wheel which is having gear tooth. Singular tooth, plural is teeth. Now, what are the types of gear trains that we have? The first one is called as a simple gear train. Second one is a compound gear train. Third one is reverted gear train. And the fourth one is epicyclic gear train. So we're going to see each one in detail now. Now first let's move on to what is a simple gear train. A simple gear train is something which has just one gear in one shaft. In each shaft there will be just one gear and it will be meshing with another gear which is in another shaft. As you can see, a driver and a follower. You should note that when the driver rotates in clockwise direction, the driven or follower rotates in the opposite direction. So it means it's in anti-clockwise direction. Now let's look at the second picture here. When the driver rotates in clockwise, imagine there is an intermediate gear which is number 2. It will rotate in the opposite, and the third gear, which is the follower, it will rotate in the clockwise direction again. So when there are odd number of gears, the input rotation will be your output rotation. The same symbol has to be followed. Next comes the third example here, where you can see a driver, a second gear, 2 intermediate gears and a follower gear. So in this case, what is happening is this rotates, the first gear rotates clockwise, then it's rotated into anti-clockwise, then the moment is transferred to clockwise again, and then it's getting transferred to anti-clockwise again. Now, we have to note certain things in gear trains. The first one is your speed ratio. Speed ratio is a very simple thing, which is speed of gear 1 by speed of gear 2 is equal to number of teeth in gear 2 by number of teeth in gear 1. So this is how we are going to calculate the speed ratio. It's the ratio of speeds. N stands for speed. Next we have train value. Train value is just the opposite of speed ratio. When you calculate with respect to the driver, 1 is your driver, 2 is your driven. When you calculate with respect to the driven, we call it as train value, which is N2 by N1 is equal to T1 by T2. Now let's see in case of a gear train which is having 4 gears in total. In that case, you see N1 by N2. For the first 1 and 2, we'll say N1 by N2 is equal to T2 by T1. And for the second and third, for that, it will be N2 by N3 is equal to T3 by T2. In total, we can say that N1 by N2 into N2 by N3 is equal to T2 by T1 into T3 by T2. Now you see, the speed of N2 is going to be common. So in that case, it will be just the driver by driven will be equal to T3 by T1. This is what I've explained to you before. Let's look at little in depth. A speed ratio is number of teeth on driven by number of teeth on drivers. So all drivens will come on top and all drivers will come on the bottom. Then comes a train value. Train value, as I said, it's the reverse of a speed ratio. So it's going to be number of teeth on driver on top and number of teeth on driven at the bottom, which is numerical, and that is numerator and denominator. Next comes compound gear train. When I explained simple gear train, I told you in each shaft there is going to be only one gear. But in a compound gear train, there will be more than 2 gears in a single shaft. If there are more than one gear in a single shaft, it's basically called a compound gear. Now you see, look at this diagram. The first gear is a single shaft and a single gear. When you come to the second portion here, it's a single shaft with two gears, one at the front and one at the back. Next comes 4 and 5 again in a single shaft, 2 gears, and 6 is a separate shaft and a separate gear. Now when one rotates, one is meshing with 2, 2 is in the same shaft which is fixed, which is 3. Then 3 is meshing with 4, and the 4 is fixed to the same shaft which is 5, and 5 is meshing with 6. You can see the meshing diagram here. 1 is meshing with 2, 2, 3 are in the same shaft, 3 is meshing with 4, 4 and 5 on the same shaft, 5 is meshing with 6. In this case, alright, you must understand that in compound gear train, if the 2 gears are in the same shaft, it's going to rotate at the same speed. This is a very, very important thing that you should know. In this case, if 2 rotates at certain speed, the same speed will be 3 as well. Then if 4 rotates at certain speed, it will be the same speed for 5 as well. So in that case, if I calculate n1 by n2 into n3 by n4 into n5 by n6 is equal to t2 by t1, this is just going to be a general thing for the whole gear train. Now what is happening is, you can neglect n2 and n3 because this n2 and n3 is going to be same speed, so I can cancel it out. Similarly, n4 and n5 I can cancel it out because it's going to run at same speed. So now you can see n1 by n6, which is your driver and driven. So you need not worry about what are the speeds of the gears in between at all. So if you know the speed of the first one and the last one, that is the input and the output, or the driver and the driven, you can figure out what is your speed of the other one if one of them is unknown. You cannot neglect the teeth because each one will have different teeth. So each gear teeth have to be taken into account. If you're going driver wise, it's going to be all drivens by number of teeth of all drivens by number of teeth of all drivers. So this is the slide. This is what I have explained you now. Speed ratio, which is speed of the first driver by speed of the last driven, which will be first driver in the sense, in case of it's a compound gear train, it's going to be product of number of teeth on the drivens. These are all drivens. Second one is a driven gear, fourth one is a driven gear, sixth one is a driven gear. So product of number of teeth on all drivens divided by product of number of teeth on all drivers. As I said, train value is the opposite of speed ratio. Next comes a reverted gear train. As you see, a reverted gear train is, as you can see, this shaft is not connected. It is just coaxial. So what happens when 4 rotates, motion is transferred to 3, from 3 and 2. 3 and 2 and 3 are on a same shaft, so it's like a compound gear. But 2 and 1 are meshing, but 1 and 4 have no connection at all. But you should know that it is in line. It's called coaxial shafts. In this case, we call it as a reverted gear train. So in this case, 1 is your input, 4 is your output. If 1 rotates, 1 meshes with 2, so 2 rotates. If 2 rotates, 3 rotates at the same speed. As I said, it's on the same shaft, so it's at the same speed. Then from 3 it gets transferred to 4. Now you see, in case of reverted gear train, the radius, as it is coaxial, the radius will be R1 plus R2 because it's at the same centers. It has same centers. So R1 plus R2's radius will be equal to R3's radius plus R4's radius. Alright, according to geometry. Now you can relate the geometry to the number of teeth because your modules are going to be same. If it is given as modules are going to be same, your radius will be equal to your number of teeth. So R1 can be taken as T1, R2 is T2, R3 is T3 and R4 as T4. Next comes your epicyclic. The fourth type of gear train is called as epicyclic gear train. In this case, the gears are mounted on a arm. In this case, you can see there is a gear here and there is a gear B. Now you see there is an arm in between which is called as C. What happens if I rotate B? The B will rotate around A. So A will be fixed based on this mount. This is called as an epicyclic gear train. Whenever an arm comes into your diagram or in place, we call it as an epicyclic gear train. As it moves around, as it goes around this gear, it's called as epi. Epi means out. Next, these are very important rules that we are going to follow. The rules are, if there is going to be external meshing in the sense two external gears are meshing together, two external gears are meshing like this, two external gears are meshing together, your sign is going to change, because if this rotates clockwise, the other one is going to rotate anti-clockwise, so you have to change signs. Then comes internal gears. Internal gears are a gear with an internal teeth in it and then an external gear inside. In that case, both the gears will rotate in the same direction. So that is the second thing you should know. Next comes the direction. We are going to assume anti-clockwise as positive and clockwise as negative. If your gear rotates anti-clockwise, then I'm going to give it a sign of plus. If it rotates clockwise, I'm going to give it a sign minus. Now, this is how the table that we will be drawing will look like. Okay, so we should remember these terms: the step number, conditions of motion, and revolution of elements. Revolution of element depends upon how many gears you have, and all those characters, everything will be taken into account. The first thing that we will be looking at is, the first condition of motion will be we will be fixing any one of the gears. We'll be fixing any one of the gears, and then we'll be moving the one which is meshing with it. Alright, so in this case you see the arm A is fixed, alright, and we are moving B around it. Alright, the arm A we are going to rotate and B is going to rotate around it. We are going to fix arm C now. Alright, now let's see, look at the first thing. The first condition is arm is fixed, gear A rotates through +1 revolution anti-clockwise, +1 revolution anti-clockwise. So in that case, your arm, as it is fixed, it's going to have 0 rotation. If I give rotation to gear A, which will be +1, as it is mentioned here, +1 rotation, I am giving it to gear A. In that case, your speed of gear B will be, it will be NB by NA is equal to TA by TB, because driver, this is your driven, right? NB, we have to find out the speed of NB. NB by NA is equal to TA by TB. I'm going to take this as TA by TB. Now look here, what is the meshing? How is the meshing happening? It is external meshing. So in this case, if this rotates clockwise, other one is going to be anti-clockwise. As I said in the beginning, in the rule, if it's external meshing, I'm going to give it a opposite sign change. Alright, so plus is going to become minus here. If this rotates clockwise, the other one is going to be anti-clockwise. So if it rotates anti-clockwise, the other one is going to be clockwise. So there is going to be a sign change. The second row, what you're going to assume is, we're going to give +x revolution to all the elements. +x, same, arm is fixed, +x, gear A rotates, +x revolution. Gear A alone rotates, +x revolution. In that case, what I'm going to do, the one is going to be replaced by x. So if I put x here, it will become -x TA by TB. Next, the third row, what you're going to do is add +y revolution to all elements, which will be +y, +y, +y. Alright. Second was, we are rotating, instead of rotating gear A for 1 revolution, I'm rotating it for x revolution. The third step is adding +y rotation to all elements. Now the total motion will be addition of second and third. It will be 0 + y is will be y, x + y is x + y, and y minus x into TA by TB. This is the tabulation method we will be following in all the sums. Now let's move on to the next slide. We are going to look at a problem now. Yes. Now look at this example 1. In an epicyclic gear train, an arm carries two gears A and B having 36 and 45 teeth respectively. If the arm rotates at 150 rpm in the anticlockwise direction about the center of the gear A, which is fixed, determine the speed of gear B. Alright. So as you can see, it's an epicyclic gear train and there is an arm which carries two gears. It's going to be just like the diagram we just saw now. Gear A is going to have 36 teeth, B is going to have 45 teeth. Now let's look at the table now. Now this is the given data. TA is 36, TB is 45, and the speed of the arm, as it is mentioned in the previous slide, speed of the arm is rotating at 150 rpm. Now you see in the table, if I say speed of arm, it means I mean y, because that's going to be the speed of the arm of our arm according to our assumption. If I say speed of gear B, it's going to be x plus y. If I want to find out the speed of gear B, it's going to be y minus x into TA by TB. This is going to be our final formula that we are going to use from the table. So you see, so what is the first thing that was asked in the question is, if the arm rotates at 150 rpm in the anticlockwise direction about the center of gear A, which is fixed. Now A is fixed. If A is fixed, there's not going to be any kind of rotation for A. Alright. Next, if I determine the speed of gear B, as I said, if I need to find out speed of gear B, what should I do? I should check this and calculate the formula. Now you see, let's get into this first thing that what you're going to find out. Anti-clockwise direction, speed of the arm, one is 150 rpm anti-clockwise. It means the speed of the arm NC is equal to 150 rpm. So what from our table, what is our speed of the arm is plus y. From that, my y is going to be 150. Why am I giving a plus sign? As I told you, the rule is going to be anti-clockwise means it's a plus sign. Alright. Next, it's mentioned as in the question, gear A is fixed. If gear A is fixed, what's my table? Gear A, it's going to be x plus y. So x plus y, if it's fixed, it will become 0. Alright. So x is going to be equal to minus y. We know y, so it's going to be minus 150 rpm. Now we need to find out the speed of gear B. Gear B is, this is the formula, y minus x into TA by TB. If I put that here, I know x, I know y, substitute it. You know TA, TB, which is given in the question, 36 and 45. You substitute it, you'll get the speed of gear B as plus 270 rpm. Alright, we have found out the first question. Next, now if the gear A, instead of being fixed, makes 300 rpm in the clockwise direction. Now in the previous criteria, the gear A was fixed. Now it's not fixed, it's going to move at 300 rpm in the clockwise direction. What will be the speed of gear B? In this case, this is going to be the second question. Gear A makes 300 rpm clockwise. Therefore, before it was 0, now it's going to be minus 300. X is going to be minus 300, so which will be x plus y. Y we already know 150, so minus 300 is minus 300 by minus 150, which is going to give you minus 450 rpm. Alright, x is going to be minus 300 minus y. Y is minus 150, which is minus 450 rpm. Next, we're going to find out the speed of gear B now. I know y already, which is 150. Now the new x is going to be minus 450. Now you're going to find out speed of gear B. So substitute x and y, TA and TB, you will get your speed of gear B as 510 rpm. It's going to be a positive sign, so it's going to be anti-clockwise direction. Now let's move on to the next sum. Yes, the second sum is going to be about a reverted epicyclic gear train. As I mentioned in the beginning, a reverted is a gear train which is having two gears in the coaxial shafts. Alright, like this. As you can see here, it's like this, two coaxial shafts. So one rotates, two rotates, 2 and 3 are at same speed, 3 and 4 are coaxial. So this is the condition, and this is going to be your question. The gear B meshes with gear E, and gear C meshes with gear D. The number of teeth on gears B, C and D are 75, 30 and 90 respectively. Alright, we don't know this gear teeth, number of teeth in gear C. Which one? We don't know about gear E now. Now how do I find it out? I already told you the radius. It's going to have common center, and that way I can find out the radius using the diameter as well. Radius and diameter are just half of each other. Diameter by 2 is going to be your radius. Now dB plus dE is equal to dC plus dd. In this case, if I it's going to have the same module, I can convert the diameters into number of teeth. dB, I'm going to use it as TB, which is number of teeth, E, then C and D. Now which one I don't know is T, which one I don't know is TE. In that case, it's going to be TC, I can substitute, D I can substitute, B I can substitute. The total is going to be, my final answer is going to be 45. So number of teeth on gear E is going to be 45. Next, now this is the table that we have found out. As you can see, now the arm is there. Now I'm going to take compound gear wheel DE as my next gear, next in the next column, and in the third column I'm going to take gear B, and then in the fourth column I'm going to take gear C. Alright, now as we saw in the previous sum, the first condition is going to be arm is fixed. I'm fixing the arm. Then compound gear DE is rotated through +1 revolutions anti-clockwise. So compound gear DE, I'm going to give it a rotation of +1 revolution. Next, in this case, what will be my speed of gear B? If I need to find out speed of gear B, I should first check with what B is meshing, either D or E, which gear. Now let's see. D is meshing with gear, B is meshing with gear E. So in that case, what will be my equation is TE by TB, because NB by NE is equal to TE by TB. So I'll get is TE by TB. Why am I giving negative sign? Because it's external meshing. Then again, C is meshing with D now. So NB for NC, if I need to find out, NC by ND is equal to TD by TC, which will be again minus, because it's again external. As you can see here, it's external meshing. Now the second row that we'll be having is arm is fixed, compound gear DE is rotated +X revolution. So DE, instead of rotating it for +1, I'm going to rotate it for +X. Now if it's going to be +X, I'm going to multiply it by X here and X here as well. Next, adding +Y revolutions to all elements. The third row, total motion is going to be second and third put up together. So this will be +Y, X plus Y, add these two and put it here, add these two and put it here. This is going to be my tabulation. So as we have completed the tabulation, now let's get back to the question what they have asked. Find the speed and direction of gear C when gear B is fixed and the arm A makes 100 RPM clockwise. So I need to find the speed of direction of gear C. If I need to find the speed of gear C, I have to take this particular value. Alright. Next. Now what is fixed? Gear B is fixed. So NB is going to be fixed. So X minus Y into TE by TB is equal to 0. So this is going to be my equation. I know number of teeth on E and number of teeth on B. If I put it, I'll get Y minus 0.66 is equal to 0. Let's keep this as one equation. Now arm A, and they have said arm A makes 100 RPM. If arm A makes 100 RPM, what is my arm speed? It's going to be plus y. If arm speed is going to be plus y, so y is equal to clockwise. Its arm is rotating clockwise, so negative. So y is equal to minus 100. If it's going to be minus 100, y, if I substitute minus 100 in this equation, it will be minus 100 minus 0.6x. So in that case, I can find out x as minus 166.67 RPM. Now, the next step is I am going to find out number of the speed of gear C. NC is equal to, I am going to write this equation y minus x in TD by TC, and then substitute x value, y value that you have found out, and then TD by TC we have to substitute it, and you'll get your RPM, speed of gear C, as 400 RPM. Alright, so these questions are very important for kinematics of machinery, and hope you all understood the basic tabulation method with basic two types, which is an epicyclic and using a reverted gear train. And in the next session, we'll be looking at some more advanced questions where we'll be dealing with planetary gears and everything. So till we meet again, God bless you. Thanks for watching.